Factor trinomials where the first value is not 1, but there's a GCF. So another way this is going to be worded is a problem is going to tell you to factor completely. Hint, hint, wink, wink. It means you're going to have to do it more than once. Kind of like when your parents tell you to clean your room and you hide things under the bed, and then you're like, no, you have to really clean it. Kind of like that. So if the directions tell you to factor completely, you're given a hint. That is your, hey, watch out. Sometimes you're not given the hint, so you have to be careful. First thing you always want to look for is the GCF. Now this has to go into all the terms. Because we have a trinomial and we have 3 pieces, I need to find a number that can divide 5, 25, and 30. I know what that is. That's 5. When you look at the variables with the exponents, you're always going to take out the smallest exponent because x squared needs at least 1x in there. X to the third needs at least 1x in there. So our GCF is 5x. So we're factoring. That 5x is part of our answer. And if I'm taking the 5x out, I need to figure out what is left over inside the parentheses. So I divide by 5x, and I'm left with x squared minus 5x plus 6. So I've taken out a common factor, I noticed it, I pulled it out, and now I have another trinomial. And this can be factored more. So multiply to give you positive 6, add to give you negative 5. Don't get these wrong. Use a calculator or not, but you should be able to get these. Negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5. So those are the numbers we're going to use. Negative 2 and negative 3. So we have x minus 2 times x minus 3 is part of your answer. And do not forget that 5x, which is a GCF, has to be left in your answer. That's how you factor trinomials with a common factor and factoring completely.